Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Hyderabad, India. In this session, we are going to study what is centroid and what is center of gravity, and the centroid of different compositions and different figures, and how to find out the centroid of composite figures. So here, what is center of gravity? Center of gravity is the term related to the three-dimensional bodies having a mass, and the orientation of the mass at a certain point, passing through the point. That point is known as the center of gravity of that body. The center of gravity is denoted by the letter CZ or simply G. Now here, the center of gravity is related to a body having a mass, certain mass. That means whole weight of the body, the point about which the whole weight of the body concentrates or passes through that point, passing through that. Now here, the center of gravity is related to three-dimensional objects. And what is centroid? Centroid is related to of the bodies having geometry, doesn't have mass. So this on the whole, when geometry is there, what will be there here? It is, we'll consider area. Area passing through, we assume that the point at which the whole area, the total area of the plane figure is assumed to be concentrated is known as the centroid of that area. The centroid is related to the plane figures such as rectangle, triangle, square, quadrilateral, circle, etc. So the centroid is also represented by CZ or simply Z. The centroid and the center of gravity are at the same point. But the point is that the meanings of the definitions of centroid and center of gravity both are same. Definitions are definitions are same, but the application of the whole weight of the body passing through one point, that is known as center of gravity. And centroid for the plane figure, the whole area, total area of the body concentrates, is assumed to be concentrated at a certain point. That point is known as centroid. So center of gravity and centroid, even though the definitions are same, but the application is clearly different. But some of the textbooks, they made a false notion that both centroid, gravity and centroid both are same. In relation to what? For the plane figures, you should not use center of gravity. It is centroid. Whereas the body, the weight of the bodies, the having a weight concentration is there, then we have to use center of gravity. So there are various various methods are there for find out this center of gravity. Centroid, we are considering here only centroid. But what is the center of mass? The point at which the total mass of the body is assumed to be concentrated. Center of gravity means total weight of the body passing through that, concentrated at a particular point. Here it is center of mass, the point at which the total mass of your body is assumed to be concentrated. Your body is having only one center of mass for all positions of the body. So what is centroid, what is center of gravity and center of mass? Okay, and the plane figures, as I mentioned here, some of the plane figures, there are different types of, by considering centroid of geometric considerations. If we consider the rectangle, the center, where is the centroid? Here I have shown here the center of gravity, but it should be what? It is the centroid. It is the centroid, but the definitions as mentioned same. Now here, the center of gravity of the uniform rod is at the middle point, and the centroid of a rectangle or parallelograms, how it happens, the diagonals, if we join, this point is known as the CZ. Now, if we consider the centroid of a uniform rod lies at the middle point at middle point means uniform rod, uniform circular rod. And the centroid of a triangle lies at the point where the three medians of the triangle meet. Suppose if we consider the triangle, the centroid of a triangle, centroid of a triangle. If we consider the median, intersecting the median of here lies at the point where the three medians of the triangle met. This is the median, here it is. This is the centroid, these are the medians. This point is known as the centroid. So if this triangle is having a height h, and here it is the base, what is the centroid? The centroid C, the distance it becomes h by 3. What is the top of the distance? The top of the distance indicates 2h by 3. This is 2h by 3 and here it is h by 3. If we consider this is the centroid. So if we want to find out the point or centroid, we need two coordinates here. What is it? Bar x and bar y. Bar x and bar y. It is symmetrical about y-axis. We are going to discuss what is symmetrical and unsymmetrical sections. So here it is symmetrical about. If we consider this is the reference axis, on this reference axis is the centroid will be there. So what is the bar x? The bar x equal to 0 and bar y equal to h by 3. Okay, and the centroid of a rectangle or a parallelogram is at the point where its diagonal meet each other. It is also the point of intersection of the lines joining the middle points of the opposite sides. So what is the meaning here? The centroid of a parallelogram or a rectangle. The centroid of a rectangle or a parallelogram, if we consider draw a rectangle, the rectangles, there are two methods are here mentioned. Parallelogram here or what? Now if you join two diagonals, this is the point of centroid. Suppose here it is, B is the base width, having it is the height is the h. What is the centroid point? The centroid is, it is h by 2, and here it is, this point is b by 2, h by 2 and b by 2. This is one method. The another method is that not only diagonals, it is also point of intersection of the lines joining the middle points of the opposite sides. What are the middle points of the opposite sides? The middle points of the opposite side means this is the middle points, and here it is the middle point, is the middle point, opposite side midpoints. This is also centroid of the parallelogram or rectangle. Okay, and it is the rectangle. What is the centroid of a square? The centroid of a square, it is not mentioned here. What is the centroid of a square? The centroid of a square is that if you consider all sides are equal, all sides are equal, it is A, and here it is also A. What is the centroid of this square? The center of the square is same as the centroid of rectangle. So by joining the two sides, this here two diagonals, this is a by 2. And what about this point? Here it is a by 2. A by 2 is the centroid of the square. So bar x, comma bar y bar x and bar y. Bar x indicate the centroid of the, here's the square in x horizontal distance, that is a by 2. Bar y, it is a by 2. All right. And suppose if we consider the centroid of a right angled triangle, if we consider the centroid of a right angled triangle, the centroid of a right angled triangle, it is same as the triangle, is the equilateral triangle or isosceles triangle. Now the point is that how to find out the centroid of this right angle triangle. Again, is the midpoint, median, one of the median here. Here it is another median, and here the midpoint passing through another median. This is the centroid C. Suppose the height is h, then it becomes h by 3. And here it is the base. So whatever this distance, it is a b by 3. If you consider from this side, that becomes a 2h by 3. And here it is 2b by 3. So alright, this is the bar x and bar y equal to h by 3 comma b by 3 from the base. If we consider the reference is the top level, top axis, then it becomes then 2h by 3 and 2b by 3. Alright, now here if we consider the centroid of the square, the another method of the centroid is joining the midpoints of the lines, opposite sides, joining. This is C. This is also another method of finding out the centroid of a square. So what about, so far we covered the centroid of triangle, equilateral triangle, right angle triangle, and the square, a parallelogram, or the rectangle. And coming to next geometry, most popular geometry, here it is the circle. What is the centroid of a circle? The centroid of a circle is at the center. That's what it is mentioned. The centroid. It is at the center. That is the centroid. The orientation, the total area of the circle is assumed to be concentrated at the center of the circle. That center is known as the centroid of a circle. Now the centroid of a circle, suppose if we consider the reference axis, when you're going to find out, when you're going to speak about the centroid, we have to know it, what is the reference axis. Now if we come to the reference axis, based on that, coming to the topic of, again it is connected to the reference axis are highly important in order to find out the symmetry. What is the symmetrical about these similar figures? Now what is the symmetry here? The symmetry is that we are going to consider symmetry. Very, very important topic here it is. Suppose if we consider the rectangle, if we consider the rectangle, this rectangle, if you fold about vertical axis and if you fold about horizontal axis, if you fold about vertical axis, both sides should be equal in geometry, then it is known as symmetrical about axis y. If you fold exactly, if you consider the rectangle, okay, or square geometry figure, then if you fold it, then it becomes exactly equivalent shape. Then it is known as, if you fold about y-axis, that means it is symmetrical about axis y. It is symmetrical about axis y. Next, the same rectangle, if you fold horizontally, the top and bottom faces should have an equal dimensions, equal geometry. Then it means it is symmetrical about axis X. So the rectangle is symmetrical about both X and Y. Alright. So it is both X and Y axis. Now coming to the reference axis, very important in order to find out the centroid. If we consider the reference axis are passing through the centroid here, these are the reference axis for this rectangle. Reference axis. Then what is the centroid position? The centroid is at 0, 0. If we consider the reference axis, very important, if we consider the reference axis is at, these are the adjacent base sides and sides. These are the reference axis. Then what is bar x comma bar y? Suppose here it is B and here it is H total. Then what is the centroid? The centroid distance becomes, what is the B by 2 comma H by 2. The centroid is at a distance of B by 2 for bar x and H by 2 for bar y. Alright. Our reference axes are, by considering, these are the two reference axes. Okay. Now if you consider the circle is having, if we consider the circle, okay, it is symmetrical about, generally if we consider the exact circle, manually drawn here, exactly circle, it is symmetrical about both x and y axis symmetry. It is symmetrical about x axis and y axis. So this is the point of centroid. These are the, if we consider the reference axis, these are the two reference axes, then what is the centroid of that reference axis? What is the centroid at the center? 0, 0. If our reference axes are, these are the reference axes, then what is the distance? Then what is the distance of this centroid? From here it is R, from here it is R. So bar x comma bar y, that is R comma R. Here these are the reference axes. Reference axis. This is also reference axis. These are the two reference axes. So based on the consideration of reference axis, the centroid is going to be defined or calculated. Okay, these are all simple plane figures and symmetry about. These are the symmetrical axes, we consider symmetrical figures. Now next, what is the unsymmetrical figures, non-symmetry? Then if we consider the T section, it is symmetrical about axis y. If we consider the T section is symmetrical about, it is symmetrical about axis y axis. Symmetrical about y axis. And what about x axis? It is not symmetrical about x axis. If you fold horizontally, horizontal axis, the top and bottom geometry is not same. It is unsymmetrical about x axis. It is symmetrical about axis y, unsymmetrical about axis x. So now the point is that We are considering to find out the reference axis of this figure, how to calculate the centroid. So it is the distance here it is the B, okay, and here it is B1, and the height is A1, and here it is A2 or A. Now it is symmetrical about axis Y. That means we can understand directly, we can tell bar Y equal to the distance. The B is a rectangle, okay, B it is a distance half of the distance, that is a B by 2. Now the centroid is an axis Y. How to find out the bar X? So the bar X comes provided if you know the area, it is area A, consider A1, and here it is A2. So there is a method of doing, we're going to continue the next class, but actually we are going to discuss about symmetrical and unsymmetrical axis, unsymmetrical figures. Now this is unsymmetrical about axis X. Next, if you want to find out the bar X symmetrical and unsymmetrical, it is the Z section is there. Is this symmetry? Tell me, is this symmetry about which axis? It is symmetry about which axis? Either x-axis or y-axis. What axis? No. If you fold, very simple. If you fold vertically, both x and y geometry is not same. It is not equally connected. Okay. Okay, it is not equally connected because the length here, it is B1, and here it is A1, and here it is B2, and here it is A2, and B3 and A3. If you fold about vertical y-axis, it is not same equal geometry. And if you fold horizontally, it is not equal geometry because it is in left side direction, it is in right side portion. Okay, the top and bottom portions both are not equal. It is having a different geometry, geometry is different. That's why it is neither, no, it is unsymmetrical about unsymmetrical section about or both x and y axis. Okay, why we have to consider all these geometries? Because these geometries are the area of cross sections. If you consider the beam means civil constructions or beams, or the cross section of components. It can be either circular cross section or square cross section, or it can be a C section, it can be a Z section, it can also be a H section. If you consider the railway track, the track which is having railway track, it is in I section. All right, it is in the geometry. In this section, it is in I section, railway track or railway. So this section you have to find out the centroid. In order to find out what is the use of the centroid calculation, the centroid calculation is required to find out the area moment of inertia I, and area moment of inertia I is required to find out the bending stress distribution and the shear stress distribution when the load is applied on this such type of sections. It is interconnected. Why should we find out centroid? Centroid is required to find out I. What is that I? Area moment of inertia. Area, why should we calculate area moment of inertia? The area moment of inertia is required to find out the section modulus. The section modulus is represents significance of section modulus is the strength of the section, strength of the beam. And also this section modulus is required to find out, to calculate the bending stress distribution, to observe the variation of the bending stress across the section of the beam, along the length of the beam. Not only bending stress, the shear stress calculations highly required. There are two types of stresses we have studied broadly category. One is normal stress, another one is shear stress. This, when the load is applied on the beam or any component, the stresses, when the load is applied, immediately stress takes place. Similarly, when there is a pressure, when there is a lot of work, we are going to multiple tasks in system, multiple tasks we are going to do it, then lot of stress will be developed. What is the stress? The physical significance of stress is how can we measure it? The quantification of stress in human body is in the form of BP, blood pressure increasing and blood pressure decreasing. And similarly, sugar levels will be increasing and decreasing. These are the variations of our human body, conscious body. Whereas unconscious entities such as the structures will represent their stresses in different forms. The bending stress, shear stress distribution, wherever different points the stresses are high. Like in our brain, no, when the pressure is too much, what happens? The blood level, sugar levels. And finally, in the case of component, what we will do? Failure of the component. In the case of the human being, the failure can be taken place. In the case of structure, the failure can be taken place at any point. Similarly, in our human body, the failure can be taken place in the brain, and it comes in the form of heart failure, in the kidney failure, in the form of nervous system breaking failure. Something different failures are there because of the stresses formation in the body, in the main, you may consciously. That for that, here what to do? In the case of structures, we have to maintain within the elastic limit. We should not apply the load beyond yield points. The within the elastic limit and calculations, what we will do? We will go for it, the stress strain curves. Alright. So in order to maintain the stress, at what load the curve goes beyond the elastic limit, it makes the undesigned zone. Within the elastic limit is the design zone. That is the deformation zone it goes. The component doesn't function properly. Similarly, the way component functions here also similar. Here also has to work within the elastic limit, within the safety zone. If you work beyond the safety zone, it attacks in different, in the form of various side effects or diseases. So how to balance our stresses? The system of balancing our stresses is called yoga process, mantra japam. Okay, that is what a different way manner. Similarly, in the case of components, what we will do within the elastic limit, within the loads, we have to apply it. Okay, that equilibrium conditions you have to apply. What are the three equilibrium conditions are? And the horizontal equilibrium, sigma h equal to 0, and vertical forces, that is sigma v equal to 0, and finally moment equilibrium, sigma m equal to 0. There is a moment equilibrium. These are the three equilibrium conditions to maintain the stability of the static structure. It is for dynamic equilibrium conditions, both are entirely different. That is algebra. That is the those are Allamraju principles which are applied. D'Alembert principles. Alright, here it is the static body. That's why we are studying different various cross sections of centroid. Okay. Now here it is unsymmetrical section. For this case of unsymmetrical, both are unsymmetry. You may consider here it is fold about vertical axis. Exactly, if you fold equally, then the geometry will not be same. The geometry is not same about vertical axis. That means it's unsymmetrical about vertical axis. And if you fold horizontally, fold horizontal axis, exactly fold it. The geometry should be same, both the top and bottom, equally should be there. Then if it is not there, then it is unsymmetrical about bar x-axis. So these are the methods, simple. So how can we find out it is symmetry and unsymmetry? Yes, which is symmetry and unsymmetry by just inspection, visual inspection also we can find out, because geometry here it is B2 and it is A2 and the bottom is A1 and B1. Both are not equal. And if we consider the unsymmetrical section of I section only, but you can see it here. If you fold about vertical axis, then it is same both left side and right side. It's the same geometry. Whatever top is there here, this portion, And here also this portion you can observe, this portion is same as right side portion. The right side portion, if you observe, is the same geometry, this one. Alright, the same. So if we see our face, the most beautiful woman means it is have a same geometry both left and right side. If it is unsymmetrical about y-axis, it is unbeautiful, ugly face. So the point is that the human faces are God made. Who has made? Okay, doctors not made. So who had made? This design is made by God such a way that it is symmetrical about which axis? Axis y. Exact. What is the portion? One side, the same symmetry should be there. The axis should pass through the which portion? The nose and lips, all these portions toward that. And including your hands and both are equal. If one hand is more length, another hand is different length, short length. No. Then it is ugly. That is called a handicapped portion of the body. Alright. The beautiful portion of the body means the human body is symmetrical about axis y, vertical axis. And it is unsymmetrical about horizontal axis. If you fold horizontally the human body, horizontal axis, it is not symmetry, top, bottom portion. So it is, we are symmetrical about axis y. So we consider here that is the symmetry and unsymmetry portion. Okay, we discuss more about symmetrical and unsymmetrical. Why we should we calculate like that? Because it is easy to calculate the centroid. If it is symmetrical about axis y, the centroid lies on that axis. It is symmetrical about axis x. And if it is symmetrical about both axis x and axis y, the intersection of the both axes, that point is the centroid. That is the concept of symmetry. Alright. So in this session, we covered what is symmetry, what is unsymmetrical sections. More application oriented we'll consider in the next session. Yes. In conclusion, in summary of this session is that what is centroid, what is center of gravity, what is center of mass, and centroid of simple plane figures, and what is symmetry, what is unsymmetry, we covered in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.